The purpose of this video is to introduce the concept of probability. The probability is a measure of how likely an event is to occur. Probability is a number between 0 and 1, where 0 indicates a probability that the event will not occur and 1 indicates that it will occur. The higher the probability of an event, the more likely it is that the event will occur. Suppose the chance of being involved in a road traffic accident was 0. This would mean it would never happen. If today is Sunday, the probability that tomorrow is Monday is certain. Therefore, the probability is 1. What is the sample space? The set of all possible outcomes of an experiment is called the sample space for the experiment. S is the notation. Now let me explain this using some examples. First, tossing a coin. What are the possible outcomes? Head and tail. Therefore, this is the sample space for this experiment. Then, rolling a die. What are the possible outcomes? This is a 6-sided die, so 1 to 6. So this is the sample space for rolling a die. What is an event? An event is a collection of outcomes for the experiment. That is, any subset of the sample space. Let me explain this using the same examples we discussed just before. Tossing a coin. The sample space is H and T. So let me define a set E1. It has one element H. So H is in S. Therefore E1 is a subset of S. So E1 is an event of S. E2, it has one element T. T is in S. Therefore, E2 is a subset of S, so E2 is an event. How about the S? Yes, S is an event because all elements in S are in S, right? The same. Yes. Therefore, it is also an event. How about the rolling a die? The sample is space 1 to 6. Now let me define E1, 6. Yes, 6 is in S. So E1 is a subset of S, therefore E1 is an event. Similarly, E2, it is also an event. Why? 2 and 3 are in S. S an event. How about this? E2. We know 2 and 3 are in S, but not 7. Therefore, E2 is not a subset of S, so it is not an event. Next, the null event, or we call empty event. An event that has no outcomes is called an empty event. The empty event never occurs. So these are the notations. You can use either one. The entire event S, the sample space, always occurs. Now consider this example. We know the sample space and we know events here. So empty set. It is also an event. Always is an event of the sample space. Similarly, we know there are 3 events so far. Actually, there are many events of this example. So you see empty is also an event. The outcomes in a sample space S are equally likely if each outcome has the same probability of occurring. Now let me explain how to find the probability of an event. Probability of an event equal number of outcomes of the event divided by number of outcomes in the sample space. This is true if a sample space S has equally likely outcomes. Now let me explain this using some examples. Tossing a coin, is it equally likely? Yes. Why? There are 2 outcomes. Coin is a fair coin. So both outcomes has same probability, right? Probability of E1 equal probability of E2 equal 1/2. How about this? Yes, this is a pair die, so each outcomes have the same probability. As an example, what is the probability of getting 1? How many ones in the sample space? Just 1. How many total? 6. Therefore 1 over 6. How about what is the probability of getting 4? How many 4s? Just 1. Total 6. Therefore probability of getting 4 is 1 over 6. Each element has the probability 1 over 6. Therefore it is equally likely. Right. How about this? What is the probability of A? How many elements in A? 2. How many elements in S? 6. Therefore, the probability of A is 2 over 6. So you can simplify to 1 over 3. How about this one? Can you find the probability of B? No. Why? B is not an event. You see 2 and 3 are in S but not 7. Therefore, B is not an event of S. Therefore, we cannot find the probability. Right. Now consider this example again. Rolling a die. You know already what are the outcomes. 1 to 6. So now let me define an event. E. The event that an even number is rolled. So what are the elements in E? It is 2, 4, 6. So what is the probability of E? How do we find the probability? How many elements in E? 3. How many total? How many elements in the sample space? 6. Therefore 3 over 6, that equal 1 over 2. Okay, how about the 2 dice? Roll 2 pair 6-sided dice, 1 blue and 1 green. How many outcomes you think? Or what are those? Yes, let me show you. These are each possible outcomes. As an example, first one, 1 and 1. That means blue die gives 1 and second dice it is also 1. And similarly, the second one, the one below first one, it is 2, 1. Blue die 2 and green one 1. So similarly, we can find the each possible outcomes. So this is the sample space. Is this equally likely? Yes. Since the dice are pair, each outcome is equally likely. So what is the probability? Each outcome has a probability of 1 over 36. Let me write the sample space in a set notation. So this is the sample space in a set notation. So the same thing we know, each outcome has the probability 1 over 36. Now how do we find the probability? Roll the sum of 5. So we need to find the how many elements in S get the sum of 5. So let me check again this. So what are the elements? That sum of 5. You know this 1, 4, next one 2, 3, next one 3, 2, next one 4, 1. So these are the elements of this event, right? Sum of 5. So we can write the probability of sum of 5 equal summation of each probabilities, right? So what is the summation of probability 1, 4? How many elements we have 1 and 4? Only 1, right? Blue is 1 and green is 4. We have only 1 element. Therefore 1 over 36. Similarly, the rest of elements have the same probabilities. So we add the probabilities of each. Then answer is 1 over 9. How about the next one? Finding the probability, roll not the sum of 5. Right. Let me consider the sample space again. So we know these 4 are the only gives the sum of 5. So the rest of the elements are not the sum of 5. So how many then? there are 32 elements, right? 32 outcomes. Oh, yes. Then how many total? 36. So 32 over 36, that means 8 over 9. Now let me explain the probability model. The probability model consists of two parts, the sample space and the probabilities to each event. Right, let me explain this using this example. Construct a probability model for rolling a single pair die with the event being the number shown on the die. First, let me write down the sample space. This is the sample space. So, we need to write the probability for each outcomes, right? Because the probability model is the sample space plus probabilities to event. Right, let me show you. So outcomes 1 to 6. Now we need to find the probability. So getting 1. How many ones we have in the sample space? Just 1. How many total? 6. Therefore 1 over 6. How about the getting 2? How many 2's? Just 1. The total 6. Therefore 1 over 6. Similarly, you can fill the rest. So you know each outcomes have the same probability. Therefore this is equally likely. And one more thing here. At all probabilities, it means 1 over 6 plus 1 over 6. Then how many times? 6 times, right? So what is the summation of this probability? It is 1. Yes, it must be always 1. Total probability always must be 1. That is the probability of the sample space. Right, I will explain that with more details later. Go to the next example. In each of the following situation 1 and 2, describe a sample space S for the random phenomenon. Right, first one. A basketball player shoots 3 free throws. You record the sequence of hits and misses. So what is the sample space? Here we record hits and misses, and he tried 3 times. Therefore, the sample space should be this. For more explanation, go to the first element. It is HHH. That means first time hit, second time hit, third time hit. Second one, HHM. That means first 2 hit, but the last one miss. So similarly, you can understand the rest. Second, a basketball player shoots 3 free throws. You record the number of baskets she makes. The first one, the same thing, but we record the hits and misses. But this one, we record the number of baskets. Okay, now go to the sample space of the first. That how many hits? 3, right? So next one, how many hits? 2. Next one, 2. Next one, how many hits? Just 1. Then similarly go to last one. How many hits? 0. Therefore, this time we record the number of baskets she makes. So, what should be the sample space? Now I explain it. Value first one 3, second one 2. Similarly, we understand the here should be 0, 1, 2, 3. Okay, go to the third one. If x is the number of baskets she makes, find the distribution of x. Yes, how do we do that? We need to find the distribution of x. First, we need to understand the x values. Yes, we already know x value. They are 0, 1, 2, 3. Now we need to find the probability. How do we find the probability for this case? Right, now we need to check the x values. Here x equal 3 because 3 hits. Next one x equal 2. How about the next one? It is also x equal 2. Similarly, you can find the x values. Right, the last one x equals 0 because no hits. Right, now what is the probability x equals 0? How many zeros you have at the top? X equals 0, just 1. How many total? The sample space 8. Therefore 1 over 8. Then go to the x equal 1. How many we have x equal 1? 3, right? Okay, total 8. Therefore 3 over 8. Similarly, you can fill the rest of the table. Actually, for this case, the third one, if x is the number of baskets she makes, find the distribution of x. So again, the sample space for this case is 0, 1, 2, 3. But I used the sample space of the first one to understand the x values.